There is a language in Western Europe that belongs to no known family. It is not Germanic. It is not Romance. It is not Celtic. Linguists have spent 2 centuries attempting to connect it to something, anything, Caucasian languages, North African tongues, ancient Iberian, even extinct speech reconstructed from fragments of inscription. None of the connections have held. The language stands alone, an isolate, surrounded on every side by Indo-European speech and offering no structural clue as to where it came from. And the people who speak it carry a biological signature almost as unusual as their grammar. They have the highest frequency of Rh-negative blood of any population on Earth. Among some communities, the rate exceeds 30%, more than double the European average and roughly 30 times the frequency found in most of East Asia. For most of the 20th century, scientists treated these 2 facts, the orphan language and the anomalous blood, as evidence of the same thing. The Basques, they believed, were the last surviving fragment of the original Europeans, a Paleolithic population that had been in place since the Ice Age, untouched by the migrations that transformed everyone around them. It was an elegant story, and it was, as the DNA would eventually show, almost entirely wrong. The Paleolithic survival hypothesis dominated Basque studies for decades. Its logic was straightforward. The Basques occupy the Western Pyrenees, straddling the border between modern Spain and France, in a landscape of steep valleys and coastal ranges that could plausibly have sheltered a population through the upheavals of European prehistory. Their language, Euskara, predates every Indo-European tongue on the continent. Their blood type distribution is a genuine statistical outlier, and early mitochondrial DNA studies in the 1990s seemed to confirm what geographers and linguists had long suspected. The Basques showed haplogroup frequencies that appeared to reflect deep European roots, lineages traceable to populations that weathered the last glacial maximum in the Franco-Cantabrian refuge of southwestern Europe. Under this model, the Basques were not simply old, they were the oldest continuously settled population in Europe, a living window into the deep Paleolithic past. Textbooks repeated this for a generation. Museum exhibits displayed it. Popular science treated it as settled. The Basques were Europe's genetic time capsule, untouched by the Neolithic farmers who arrived from the Near East, untouched by the Bronze Age pastoralists who swept in from the steppe. A population frozen in place while the continent changed around them. Then whole genome sequencing arrived, and the picture fractured. In 2015, a team led by population geneticist Torsten Gunther at Uppsala University, working alongside Cristina Valdiosera and Mattias Jakobsson, published a study in the Proceedings of the National Academy of Sciences that redrew the map of Basque origins. The team had extracted and sequenced ancient DNA from 8 individuals buried in the El Portalon cave at the Sierra de Atapuerca complex in northern Spain. The remains dated to between 3,500 and 5,500 years ago, the Chalcolithic and early Bronze Age, and they were associated with farming cultures, not hunter-gatherer ones. Pottery, domesticated animal remains, and stone tools placed these people firmly in the Neolithic agricultural tradition. What the genomes revealed was that these ancient Iberian farmers shared ancestry with other early European farming populations who had migrated from the Near East. They were not Paleolithic holdouts. They were part of the continental wave of agricultural expansion. And of all modern populations tested, these ancient farmers showed the greatest genetic affinity not to Sardinians, the usual benchmark for early farmer ancestry, but to the Basques. The population that was supposed to predate farming turned out to be descended from farmers. 2 frameworks had to be weighed against each other, and neither survived intact. The first was the Paleolithic continuity model. It still had evidence in its favor. A 2006 study led by Ana Maria Gonzalez at the University of La Laguna identified mitochondrial subhaplogroup U8A in Basque populations, a lineage whose divergence dates placed its origin in the Upper Paleolithic, potentially over 30,000 years ago. This was a real and ancient maternal signal. But a maternal lineage is not a whole population. The full genomic picture from El Portalon showed that the bulk of Basque ancestry derived from Neolithic farmers who had mixed with local Mesolithic hunter-gatherers upon arriving in Iberia. The ancient U8A lineage was genuine, but it was a thread woven into a much larger fabric, not the fabric itself. The second framework, Neolithic farmer descent, fit the El Portalon data cleanly, but raised its own problem. If the Basques were simply early farmers who isolated after arrival, their genetic profile should have resembled Sardinians, the other European population widely understood as a preserved snapshot of early farmer ancestry. It did not. The Basques carried something additional, something the Sardinians mostly lacked, and it pointed to a migration event the Neolithic model could not explain. Both theories captured a piece of the truth. Neither captured enough. In 2019, a study published in Science by Inigo Olalde, David Reich, Carles Lalueza-Fox, and over 100 collaborators assembled genome-wide data from 271 ancient Iberians spanning 8,000 years. For the Basques, the findings were transformative. The study documented that, beginning around 2000 BCE, populations carrying ancestry from the Pontic-Caspian steppe entered the Iberian Peninsula and, over roughly 4 centuries, replaced approximately 40% of the existing ancestry. The Y chromosome replacement was even more dramatic. The paternal lineages present in Copper Age Iberia were almost entirely supplanted by a single lineage of steppe origin, R1b-M269. This was the same migration event linked across the rest of Europe to the spread of Indo-European languages. And the Basques were not exempt. They carry steppe ancestry. They carry R1b at frequencies among the highest in Europe. And yet they speak Euskara, the only surviving pre-Indo-European language in Western Europe. The study's conclusion was precise. Present-day Basques are best described as a typical Iron Age population without the admixture events that later affected the rest of Iberia. They are not Paleolithic survivors. They are not untouched Neolithic farmers. They are a Bronze Age population that received the same steppe migration as their neighbors, then stopped mixing while everyone else continued. What the science reveals overturns almost everything most people were taught, and it does so not by diminishing the story, but by making it stranger and more human. Imagine you have always understood yourself as the last inheritor of something ancient, a tradition older than any surrounding culture, a bloodline stretching back beyond the reach of written history. And then someone shows you the evidence, carefully, precisely, and tells you that the reality is different. You are not the unchanged remnant. You are something assembled from multiple migrations across multiple millennia, Paleolithic hunters, Neolithic farmers, Bronze Age pastoralists from the eastern steppe. Layers, not a single unbroken thread. Your first instinct might be that something has been taken from you, but sit with it. Because what actually emerges is not a smaller story. It is a larger one. The continuity is real, but it does not run through the blood in the way anyone assumed. It runs through something else entirely, something that the genome, for all its precision, cannot fully explain. That something is the language. In 2021, a study published in Current Biology by Flores-Bello, David Comas, and colleagues at Pompeu Fabra University conducted the most comprehensive genomic sampling of the Basque population to date. The team analyzed approximately 629,000 genome-wide variants across 1,970 modern and ancient individuals, including 190 newly sampled people from 18 locations across the Basque country and the surrounding region. What they found added a dimension earlier studies could not resolve. There was sharp genetic heterogeneity within the Basque population itself, and it correlated with geography and, critically, with the historical boundaries of Euskara. Communities where Euskara had been continuously spoken showed the strongest genetic differentiation from surrounding non-Basque populations. Communities where the language had been lost showed intermediate profiles, sitting between Basque and non-Basque clusters. The implication was striking. The language had not merely survived because the population was isolated. The language itself had functioned as the isolating mechanism. Euskara, by creating a cultural and communicative boundary, had reduced gene flow across that boundary for roughly 3,000 years. The genome did not preserve the language preserved the genome. This reframes Basque identity in a way that is, if anything, more remarkable than the old narrative. Under the Paleolithic model, the Basques were extraordinary because of what they had not experienced. Migrations that passed them by, changes that never reached them. Under the evidence as it now stands, the Basques are extraordinary because of what they chose to maintain. The steppe migration reached them. The genetic transformation touched them. The pressure to assimilate into the Indo-European linguistic world surrounded them for millennia. And still, Euskara survived. Not because of mountains alone, not because of blood alone, but because a community of speakers, generation after generation, continued to transmit a language that connected them to one another and, in doing so, maintained a boundary that shaped their biology as profoundly as their biology shaped them. The Basques were never Europe's untouched isolate. They were something more interesting, a population that absorbed every major migration event of European prehistory, carried the genetic evidence of all of them, and still held onto the one thing that no genome can encode: their word for the world. The Basques were never who we thought they were, but what they actually are tells us something about every population we think we understand. The clean stories, the pure lineages, the singular origins, they almost never survive contact with the evidence. What survives instead is something more honest and more durable. Complexity held together by choice. If this changed how you think about what it means to be an ancient people, subscribing means the next piece of evidence we uncover will reach you before most people hear about it. And if you think this story deserves to be heard more widely, the like button is the single best way to make that happen. There is another population in European history whose DNA contradicts almost everything the textbooks claim, and that video is on screen now. Before you go, I want to ask you something. If you discovered that your own ancestry was more layered than you had been told, would that feel like a loss or like an expansion? Tell me in the comments. History is not a fixed point. It is a language we are still learning to read.